Hey students, we are in the radical operations portion of your packet, and we're going to start with all of these roots here. So if you recall, a radical is this wacky symbol here that we normally call a square root, but it also includes things like cube roots, fourth roots, all of those. So the first one is the square root of 1 is 1. All of these lists right here at the top are perfect squares. So when we take the square root of them, we get a whole number answer. Square root of 4 is 2. Square root of 9 is 3. Square root of 16 is 4. Square root of 25 is 5. Square root of 36 is 6. 49 is 7. 64 is 8. Square root of 81 is 9. And square root of 100 is 10. The same is true for these. These are cube roots instead, and we'll get to those in just a second. So cube root of 1 is 1, 2, 3, 4, 6, 7, 8, 9, 10. So if you guys recall, this is the list that you'll use to help you find those to simplify square roots and cube roots. So step 1 for simplifying square roots. We are going to rewrite the inside as a perfect square and a number multiplying. So if we look at this class example here, I'm going to look at the number 90 because that's the one on the inside, and I'm going to figure out which one of these perfect squares, the numbers on the very top here, divide evenly into 90 so that it can be a perfect square times another number. If I had tested some of these out, one of the ones that I know is going to work is 9 times 10. And that works because 9 is a perfect square. So I'm going to rewrite this as 9 times 10 on the inside. Step 2, simplify the perfect square. And bring it outside. Multiply the outsides together. So my perfect square is 9. We know that because it's from my list. So right here, I can take the square root of 9. And the square root of 9 is 3, so that's going to come on the outside. Notice I can't take the square root of 10, so that's going to stay on the inside. And then we already had this 7 out here, and those outsides are going to multiply. 7 times 3 gets us 21. And so this is our answer. This brings us to our last step, step 3, check if simplified completely. And to do that, we're just going to take a look at the inside again, and we're going to see if there's any perfect squares that divide into it. I know that 4 does not divide into 10, 9, 16, any numbers like that, so this is our final answer. All right, next up, simplifying cube roots. This is going to be the same process as above. But we're going to use the cube root list. So that means instead of these top numbers, I'm going to use this bottom row. I'm going to figure out which one divides into 875. Give Miss Horn just a second while she grabs her calculator. All right, and I saw this 5 in the 875, so I knew I was going to try one of the numbers on this list that ended with a 5. So I did 875 divided by 125 in my calculator, and I got 7. So what that tells me is that I can rewrite my inside as 125 times 7. Now we're going to simplify the perfect cube in this case. So my perfect cube is the 125 from our list. The cube root of 125 according to above is 5, so that comes on the outside. And since we don't know the cube root of 7, that stays on the inside. To check if this is all simplified, I'm going to look if there's any cubes that divide into 7, and there are not. So this right here is our final answer.